So let's move on to question 4. What? Look at reading. Oh my goodness. Oh, I feel it for you, dog. I feel it for you. After I go through all of that in question 1 to 3, and then I come and see all this reading here, I was just going to sit down and look at the ceiling for a little bit and say, all right, I still have a whole 45 minutes. I'm going to take my time with this. When you see all that reading and thing there, after you go through questions 1 to 3, this is not cool. This is not cool. All right, after all the papers that I do for the new syllabus so far, I'm calling it, I'm declaring it. This one is the hardest IT paper under the new syllabus. So chances are it's late in the night and you're watching this past paper video hoping that you get the answers to the past paper that you've been looking for all this time, and you're happy that it actually exists on YouTube. Well, don't leave it up to the YouTube algorithm to show you the rest of answers. I have an app that's called Learn It by makeITsimpleTT, and it has all the past paper answers in chronological order for the past 10 years, maybe 12, depending on the time that you're watching this video. It might have a lot more. The app is called Learn It. Go find it, download it. Link will be in the description. And if you want to see the PDF with the actual Crapperfoot handwriting that I have with the answers, so you could actually scroll through the PDF and look at the answers as it was written instead of watching the video, hey, you could do that too. Download the app now. Alright, back to the answers. Number 4. A credit union gives loans of $10,000 or a fixed monthly interest rate of 1% on the principal amount. The monthly payment amount is a fixed $1,000. Yeah. So that child that come out to the exam and be like, sir, I didn't sign up for accounts, you know. I didn't sign up for POB. Like, I don't know what he was thinking about in this last question. Anyhow, the amount paid to the principal each month is the monthly payment amount minus the interest paid for the month. Thanks. The pseudocode below will print a payment schedule showing the principal, the payment made to the principal, and the interest charged for each month. Once the principal is greater than 0, the payment schedule will also print the total amount paid to the principal and the total amount of interest paid in the number of fingers paid. Well, I ain't lying to you. I just read all that and I really can't remember what I read. I just read it and I was like, what did I just read? Alright. Let me go. Let me see what these. Set principal to 10,000, set monthly payment to 1,000, set monthly interest to 0.01. Write principal payment interest. Okay, while principal is greater than 0, do. It means while you still have money to pay, set the interest to principal by monthly interest. Okay. And set payment to monthly payment minus interest. Total interest is total interest plus interest. Set total payment to total payment. Write it out. Okay, so set new principal to principal minus payment, carry up the count by 1, end the while. Alright, so we basically going to stay in this loop here. And we will stay in this loop, and this is basically going to count down the payments each time. At the end of the loop, you will tell them how much you paid in all, how much interest you paid in all, and the count. Okay, cool. I understand what's taking place here. Identify two variables which when added will always be equal to the monthly. No. No. I understand that is payment and interest, but why are you putting students through the interpretation of a simple interest question? Why the interpretation of a simple interest question? I mean, I'm not buying into the hype, but after such a challenging question 1 to 3, you really shouldn't do this to people for question 4. You really shouldn't do this. Identify two variables which when added will always be equal to the monthly repayment amount of 1,000. Now let me interpret with my business brain what is taking place. Two variables when added will always be equal to the monthly repayment amount of $1,000. If I have to pay back $1,000 every month, that means I need to read over the question. No, these are maths question. Those are maths question. I'll make sure I'm making sense.
One hour later.
All right. No. All right, cool. I mean, of course, I didn't just call Kerwin to find out about simple interest. No, of course not. I checking to see if they had any clues in the question. The amount paid to the principal each month is the monthly payment minus the interest paid for the month. The amount paid is the monthly payment minus the interest paid each month. Set payment. Payment is equal to monthly payment minus interest. So therefore, the payment here, this is the $1,000. So the payment is the monthly payment minus interest. Two variables, which when added will always be equal to the monthly repayment. Payment plus interest. You're basically pulling out this equation here and you're transposing, well, not transposing what you're saying. If payment is equal to monthly payment plus interest, if you take the interest and put it outside, payment plus interest is equal to monthly payment. Quick maths. Cool. 2 marks. That was not necessary. Yeah, okay, cool. Alright, the pseudocode has a logic error. Identify the line with the error and make the necessary corrections. Now you're telling me to have a logic error? Logically, the interest is equal to principal by the monthly interest. Cool. That makes sense. Payment is equal to monthly payment minus interest. Total interest is equal to total interest plus interest. Total payment is equal to total payment plus payment. Right principal. Set new principal is equal to principal minus payment. New principal. What is new principal? Where this came from? Why is there something called new principal? That's the first time that new principal is actually in the algorithm. Yeah, new principal is not a thing. Alright, clearly there's a problem here. New principal is not a variable. So principal is equal to principal minus payment. Yeah. Yeah. New principal should just be principal. Right, so a logic error is not a syntax error. Syntax errors would be like, quotation marks, minus, and stuff like that. But a logic error is some sort of calculation mistake or issue. This is clearly not a thing, because new principal is not a variable. The principal that you want to check every time here is a principal greater than 0. So this here shouldn't be new principal, it should just be principal. Logically, it won't run. It won't run. Yeah. But again, if you don't understand this, I don't blame you. I don't blame you. I honestly cannot blame you if you didn't understand this. Because in the heat of the exam, when you see this isn't really clicking with you, especially if you're not mathematically oriented. I mean, there are algorithms that are logical, where you could go through the logic of it and make sense of what's supposed to take place. But this is a little more mathematical than logical. And it kind of assumes that you need to know about simple interest, you need to know about banks and that kind of thing. Yeah. Yeah, right. So yeah, certain count is equal to count plus one, that doing nothing to nobody. This is not a logic error. That's cool. Everything's good. The only logic error here is that new principle is introduced, and new principle is never a variable that they use in the program. Yeah. For the people in chat that's saying count not set at the beginning, that's not a logic error. Because the value for count not affecting anything in any way. I don't think so. I mean, they do have to show the count at the end, and if the count wasn't set to 0 at the start, then yeah, okay. You might get count being a logic error. You could say line 12 if you want. So we could say 11 and 12. But I know for sure. Well, I shouldn't say for sure, but I know they would have most likely, the answer sheet will most likely be looking at line 11. But the examiners will have to accept count being an issue. They will have to accept count. Count not being declared up here. They should set count to 0 at the start. They should. Whether it falls in the context of a logic error, I'm not 100% sure that is a logical error, because the logic of the program will still work, because count doesn't affect the logic of the program. So that's up to the examiners. Identify the stage in the program implementation where the type of error stated in I will show up. Compilation. No. I'll say the consequences of the error. It will be in the execution. Oh wait. Oh, depending on which error that you state. Oh, now we have a problem. We have a problem. Payment is equal to monthly payment. Line 7 has payment is equal to monthly payment minus interest. But no. You're really supposed to pay monthly payment plus interest. Something adding up. The amount paid to the principal each month is the monthly payment minus the interest. No, they said it here. The monthly payment minus the interest paid for the month. Minus the interest paid for the month. No, the question says minus the interest, so therefore this is acceptable. But how the question say to do? Not making sense to me. Well, they're ready to throw away this question, you know. I'm ready to throw away this question. It seems like there is a error in the question because they're treating it like code, but it's really pseudocode. So when you reach to this part here, identify the stage in your program implementation where this error will show up. It will show up in execution because the calculation will be wrong. But for error to show up in compilation, that means you need to have a syntax error. You can't get a syntax error in pseudocode. So I will put execution because the calculation will be wrong. Or the calculation will be wrong for the new principal. Alright, so I'll stick with line 11 being the major issue. Line 7, shaky to me. I get where you're coming from. And the count 1, I get where you're coming from too. Somebody on some examiner table, examiner group when they're marking this for CXC, going to have a long discussion about what the answer for this question really is supposed to be. I could see them arguing a lot about this question. I could see it. Yeah. Because the interpretation of how the simple interest is supposed to go according to this paragraph here not making sense. But it's not adding up to me. But okay. Steady type of looping construct using the pseudocode as a while loop. So just one reason why looping construct was used in the pseudocode. Why looping construct was used? Because it will keep going as long as the principal is not paid off or is not less than 0, right? Explain one other named looping construct that could be used in the program. One other named looping construct. Explain one other named looping construct. You could use a repeat until. Because it is indefinite. Indefinite, just like a while loop. Yeah. All right. Oh, wait. No. Let's go back. The reason you can't use a for loop here is because it's an indefinite loop. If you use a for loop, that means you know exactly how much times it's going to run, but we don't know how much times it's going to run. So you could only use a repeat until because you have to use an indefinite loop and they started up using a while loop, so you have to use that. Now this part here, this is an issue. This is a big issue. Because they say complete the following trace table by inserting the missing values for the variable in each row representing the first 3 times the pseudocode loops. But they literally just told you that the pseudocode has a logic error. So if the pseudocode has a logic error, and I'm going to run a trace table on an algorithm that has bad logic, I'm basically going to work out a trace table on something that is illogical. All right, let's do it and see. I really gonna go through this table and this thing on our trace table, right? But why would they ask you to do a trace table on something they know have a logic error? Okay. All right, so if the principal is 10,000, 10,000 multiplied by all the monthly interest, 0.01. That's 1 over 100. That's $100. Monthly interest is 100. Cool. That's easy. Yeah. The payment is now monthly payment minus interest. Monthly payment starts off at 1,000, so 1,000 minus the interest is 900. According to them, yeah, 10,000 multiplied by 0.01 will give me 100, right? And then the next job is to take the monthly payment that I just got, which is monthly payment is $1,000 minus the interest, which is 100. That's supposed to be 900, so the payment is 900. The amount of money you have to pay in monthly interest is $100 for the first thing, because you multiply according to the algorithm. You're going to say monthly interest, which is 0.01 multiplied by the principal, which is 10,000. That's gonna give you 100. So interest, but they have monthly interest here. Monthly interest is not a number. Monthly interest is a percentage. Is it? Yeah, monthly interest is 0.01. Y'all, hold on. Stop.
I have to stay here. What is this? No, tell me what is this? I want to know what is this. This is madness.
They crazy. Look, monthly interest. The final value for monthly interest here is a number, is a monetary value, $81.91. But it is clear from the algorithm. Watch this. I'm gonna scroll back up. Monthly interest is a percentage, like 0.01. So there's no way monthly interest could end up being a number, being a monetary number. That can't make sense. Y'all, all is seen, right? All is seen, what I seen, right? Monthly interest in the algorithm is 0.01. That means it's a percentage. But they have monthly interest as a monetary value in the trace table. That can't be anything but error, because obviously what they want to do is they don't want to put up monthly interest, they want it to calculate interest. But they label it as monthly interest. No, somebody was... Somebody was high when he was doing this all. No, it's funny though. It's real funny. It's no way you could work this out, you know. You cannot work this out because monthly interest could never be a monetary value. Never. I feel somebody was just doing too much, boy. Somebody was just doing too much and say, hey, I'm gonna come up with the greatest algorithm pseudocode question ever. And I'm gonna make this thing, you know, so in depth and unique and all that stuff. And they just did too much. Like they did too much. So nah. The minute I was marking, the first thing I go down and tell them is, yeah, you see this question here? You'll have to take that out. Because you clearly misled students by saying monthly interest and put a monetary number inside here. That can't work. That's impossible. Yeah, all the teachers that know what as mark, I go down and talk to them about this. I'm gonna be like, listen, when all they go and mark, tell them about that. This can't work. First of all, it are two things wrong. They want you to do a trace table on an algorithm that they said already has a logic error. And you had to correct the logic error. So they didn't say do the trace table on the corrected logic error, you know. They said do the trace table on the algorithm that I had before. Second of all, the trace table has monthly interest with a monetary value. Yeah, let's just move on, kids. Let's just move on. Let's move on quietly. Alright, the advent of COVID-19 pandemic has resulted in the increase in connectivity and online activities. For example, telecommuting, cybercriminal activity, and a greater use of cloud. Describe the concept of telecommuting and one reason why telecommuting is so impactful. This is telecommuting is working from a remote location but connecting to the office using telecommunication tools. Something like that, right? Working from a remote location using telecommunication tools. Yeah. Right. Describe the term denial of service attack, given one example. Alright, denial of service attack is when a server is blocked, is swarmed with fake requests and the legitimate requests are not the legitimate requests do not get any attention. Example, a website being inaccessible, like Facebook. or Twitter. Right, so a denial of service attack is a bunch of fake requests blocking legitimate requests. Alright. State one similarity and one difference between Bluetooth and Wi-Fi. Similarity is radio waves. Difference, the distance signals can travel. State two advantages and one advantage of buying software applications stored in the cloud. Access from multiple devices. So if the device is lost, the data is still there. And the next advantage is that you can share you can share. This is software applications in the cloud. It's not storing files. Software application in the cloud, access from multiple devices and devices also in the cloud. Your work is saved automatically. There are many other things I could put inside here. Access to multiple devices, work stored automatically, you have backups, you could share, all that stuff, you could do that. Disadvantage, needs the internet. Not the biggest one. Yeah, needs the internet to work. Yeah, remote access on multiple devices, wherever. Like this question here, you're really gonna have too much issues with that. You could basically common sense that out. Okay. Alright. So let's take stock of what just happened here.